Ever dreamt of a career at the forefront of human knowledge but thought it meant endless PhDs and dusty lecture halls? What if I told you the most impactful work in quantum doesn't always happen in academia? That's right. While the idea of being a quantum physicist often brings to mind traditional academic paths, there's a huge world out there where quantum breakthroughs are happening outside the classroom. Quantum physics isn't just for those tucked away in labs conducting theoretical experiments. In fact, the real-world applications of quantum technology are advancing so quickly that industries everywhere are investing billions of dollars in this next-generation science. Companies like Google, IBM, and even startups like Cold Quanta are leading the charge, using quantum mechanics to shape everything from computing to communications. This isn't the quantum world of the future, it's the quantum world of now. With these advancements, it's easy to overlook the fact that quantum research is already having a huge real-world impact. Take drug discovery, for example. With quantum computers, scientists are able to simulate molecular interactions at an unprecedented level of detail. This breakthrough can drastically reduce the time and costs involved in developing new medications. Similarly, industries like finance are already utilizing quantum algorithms to enhance stock market predictions or optimize asset portfolios. Logistics is another key area benefiting from quantum technologies. By using quantum computing for more efficient supply chain management, companies are dramatically improving how goods are transported and delivered. These are just a few examples of how quantum is revolutionizing multiple fields in ways we never imagined. But the real twist here? Quantum work is expanding beyond the academic sphere. You don't need to spend your life teaching in a lecture hall to shape the future of quantum technology. Industries are looking for innovators, thinkers, and practical problem solvers who can take quantum theory and apply it to real-world challenges. In this speech, I'm going to show you how to tap into this exciting field, how industries are actively recruiting for quantum expertise, and how you can dive in without being confined to academia. To understand how to break into the quantum field, we first need to explore what industries are really looking for. You see, while a lot of quantum talent has traditionally come from academia, industries today aren't just searching for PhDs in theoretical physics. They need professionals who can bridge the gap between theory and practical application. So if you've ever thought that a background in pure physics was your only option, think again. Industries are looking for a wide range of skill sets to fill roles in quantum research and development, and that's where you can make your mark. Let's start with the most obvious skill set: theoretical knowledge. If you're already familiar with quantum mechanics or have a background in physics, you're off to a great start. However, in the real world, industries aren't just looking for theoretical physicists to formulate laws. They need professionals who can turn these ideas into tangible, functioning technology. That's why engineers are in high demand. Quantum engineers specialize in building the hardware that powers quantum computers. Their job involves a unique mix of traditional engineering and quantum knowledge, as they work to create machines that leverage quantum principles to perform complex calculations. But this isn't just about building hardware, it's also about software. Quantum computing requires specialized software developers who can write algorithms that harness the power of quantum computing systems. If you're skilled in programming languages such as Python, C++, or specialized quantum languages like Qt or Quipper, your skills could be highly valuable. But the quantum skill set doesn't stop with engineers and software developers. Quantum research also requires a surprising number of data scientists. Because quantum systems generate a vast amount of data, industries need experts who can analyze and interpret this information. Data scientists are needed to develop tools that help decode quantum systems, optimize performance, and detect patterns in quantum experiments. If you have a background in data science, machine learning, or statistics, there's a place for you in quantum fields. It's about making sense of all that raw quantum data and turning it into actionable insights. However, technical skills alone aren't enough. In today's fast-moving quantum landscape, soft skills are just as essential. Collaboration, communication, and adaptability are key in any quantum job. The field is evolving rapidly, and quantum projects often require cross-disciplinary teams working together to achieve breakthroughs. Communication is particularly important because many quantum concepts are difficult to explain to those without a physics background. Whether you're pitching a new idea to executives, explaining your findings to a team, or presenting at a conference, the ability to convey complex information in a clear and understandable way is critical. And because the quantum landscape is still so new, professionals must be adaptable. Being open to learning new technologies, adjusting to changes, and experimenting with fresh ideas are the attributes of a successful quantum professional. As quantum technologies continue to evolve, the number of industries that will need quantum professionals will only expand. The world of quantum computing, quantum sensing, and quantum cryptography is still in its infancy, and these industries are in desperate need of skilled workers. Let's take a closer look at some of the hot roles emerging in these areas. The first and most obvious area is quantum computing. This is where the hype is, and rightly so. Quantum computers promise to solve problems that traditional computers would take thousands of years to process. From drug development to machine learning, quantum computing is set to change everything. As a result, the demand for quantum computing engineers, quantum algorithm developers, and quantum software developers is skyrocketing. If you're someone who loves working on cutting-edge technology, then building the next generation of quantum computers could be your ideal role. Next, we have quantum sensing and metrology. While quantum computers might be the flashy star of the show, quantum sensing is a quiet revolution happening right alongside it. Quantum sensors are capable of making measurements with precision and sensitivity that goes far beyond what we've ever been able to achieve before. They can be used in everything from medical imaging to navigation systems. For example, quantum sensors could make MRI machines vastly more powerful or help navigate drones with incredible accuracy. If you have a background in physics or engineering, quantum sensing could be a fascinating and impactful field to explore. Then there's quantum cryptography and quantum communication. With the growing concerns about cybersecurity and data privacy, quantum cryptography holds the key to securing communications in the digital age. Unlike classical encryption methods, quantum encryption is theoretically unbreakable, which makes it vital for protecting sensitive data. Professionals who can develop and deploy quantum-safe encryption techniques will be in high demand, especially as the world moves toward quantum communication networks. If you have a background in cryptography or cybersecurity, this could be the next frontier in your career. As quantum technology continues to evolve, new industries will undoubtedly emerge, creating a wide range of opportunities for those ready to step into this exciting field. But how do you break into these high-demand roles? Now that you understand the industries and roles, let's talk about how you can actually get started on your quantum journey. Traditional academia is one way to enter the quantum field, but it's not the only way. The landscape of quantum education is evolving, and there are a number of alternative learning pathways to help you gain the skills needed to enter this field. Online courses, boot camps, and industry-sponsored programs have become incredibly popular as alternative educational pathways. These programs are designed to provide you with the practical skills you need to succeed in the quantum job market, and they often do so in a fraction of the time it would take through a traditional PhD. For example, you can find boot camps that teach quantum programming or quantum engineering, which will give you hands-on experience with the tools and technologies that are actually used in the quantum industry. These alternative programs are a great way to quickly gain expertise in a specific area and build up your resume with real-world skills. Networking is also critical when pursuing a quantum career. Even if you don't have a traditional academic background, there are still many ways to meet people in the industry. Conferences, meetups, and workshops are great places to learn from experts and connect with potential employers. LinkedIn is another powerful tool for finding opportunities and building relationships with people who are already working in the field. Don't be afraid to reach out to industry professionals. Many are eager to mentor and share insights about breaking into the quantum space. Finally, crafting your personal narrative is key. When you transition into the quantum field, you'll need to highlight your transferable skills. Perhaps you have a background in engineering, computer science, or data analytics. Whatever your background, there are likely transferable skills that will serve you well in the quantum world. Focus on how your experiences can add value to the roles you're pursuing, and be sure to emphasize your willingness to learn and adapt to new challenges. Now let's talk about the next steps. If you're serious about a career in quantum, the first thing you need to do is start exploring companies and job descriptions that align with your interests. Look at major players like IBM, Google, and Rigetti Computing. These companies have cutting-edge quantum research teams and offer plenty of entry-level roles. You'll want to start by identifying what roles are in demand and tailor your learning toward those specific skills. Another great way to build your portfolio is through hands-on projects and open-source contributions. Many quantum companies welcome contributions to their open-source projects, which is a great way to gain experience, build your portfolio, and connect with the community. Even if you're still learning, contributing to open-source projects can help you understand real-world quantum problems and start developing the skills needed for full-time roles. The world of quantum is rapidly evolving, and the career opportunities are vast. Whether you're interested in working with quantum computers, quantum cryptography, or quantum sensing, the possibilities are endless. With the right mix of skills, networking, and a willingness to keep learning, you can find your place in this exciting and lucrative field. The quantum future is just beginning, and the opportunities are there for those who are ready to seize them. One of the best ways to make a meaningful entry into the quantum field is to start building a portfolio of hands-on projects. Quantum technologies are still very much in the experimental phase, and as such, companies and organizations in the field are always looking for proof that candidates can actually apply the knowledge they claim to have. It's not just about knowing the theory, it's about demonstrating that you can turn theory into action. Hands-on projects show potential employers that you're not just another academic. You're someone who can solve real-world quantum challenges. Start by working on personal projects that align with your interests. If you're interested in quantum programming, there are quantum computing platforms like IBM's Qiskit, Google's Cirq, and Microsoft's Quantum Development Kit, where you can write and run quantum algorithms in real-world environments. If you prefer working on hardware, you can explore quantum circuit design or dive into quantum sensors and metrology. Document these projects thoroughly on your portfolio, showcasing the problems you solved and the technologies you applied. This shows employers that you're proactive, knowledgeable, and ready to contribute to their work from day one. Open source contributions are another excellent way to build credibility in the quantum field. Many quantum technology companies and research groups share their work openly and welcome contributions from the community. By contributing to these open source projects, you can deepen your knowledge of quantum systems, collaborate with experts in the field, and demonstrate your commitment to staying up to date with the latest advancements.